This is a help video on how to use the notes for the Unit 3 assessment. I'm going to be using notes. Those notes can be found in the 1016 session under resources. I suggest you use them because that's what I'm using. So our first problem is going to use one of those notes on polynomial behavior, and it talks about minimums and maximums. All right, notice that maximums looks like this. So the graph is going up to a turning point and then down. Minimums look like this, where the graph is going down to a turning point or down to a minimum and then turning and going up. All right, so over here, you need to look at this graph and say, where are the minimums? That's what it asks for. It says, where are the relative minimums? All right, and how many are there? All right, so you just need to focus on that. The second one is the same type of a problem, and it asks for the maximums. So the maximums, where do you see parts of the graph that look like this? The next two questions ask about characteristics of these graphs. Where are intervals positive and negative, or where are intervals increasing and decreasing? So you can find this handy little chart in your resources that describes increasing and decreasing intervals and positive and negative intervals. Okay, so increasing intervals are going up between the turning points, and decreasing intervals are going down between the turning points. For positive and negative, now we're looking for the humps in effect. So how much of the hump is positive? That's a positive interval. And where are the humps negative? All right, so we can see that this one is positive between these and negative below here between those. So now you want to look at your interval and read the problem carefully. And it says from D to E. All right, so from D to E. All right, so is this interval increasing or decreasing? And is this interval positive or negative? All right, and you can look at the chart for reference on both of those things. The next problem is the same, except the interval is different from B to C. So be sure and check the right interval. The next two problems ask for end behavior. So just a quick reminder on end behavior. All we have to do is look at the arrows to find the end behavior. And which direction is that end behavior going? In this case, it's going up, so it's going towards infinity. If we had another graph that looked like this part of the graph would be going towards negative infinity, while this part of the graph went towards infinity. All right, but in this case, both sections are going positive. There is a graph, there is a note, and all you need to do is match up your end behavior with one of these four situations here. There's only four. All right, and we can see that this graph matches right there. And so that is your answer for this graph. So you need to come back over and match up that answer with these answers. I would point out that Delta Math uses a y instead of f of x. Osborne High School uses f of x, but you can just substitute a y right here instead of the f of x, because y and f of x are the same thing, right? Just two different names for the same thing. All right, and so that's this graph, and then this graph. So we look at the endpoints and match them up to the graph, and then match up our answer. All right, our next problems are also about end behavior, but you have to figure it out from an equation. Notice that our chart over here also has words on it: odd, even, odd positive, odd negative, and even negative. Those describe the leading term of your polynomial. In this case, it's 3x to the 6th. We use the exponent. We use the exponent for even or odd. In this case, 6 is an even number, so 6 is even. And then we use the leading coefficient for positive, negative. All right, and 3 is positive. All right, so we're going to go back at our chart and look for something that is even and positive. And there we have even and positive right at the front. And so that's going to be your answer right there. We go back to the next one. Now, the next one has we look at our leading term here, we find that 3 is an odd number. All right, so this is an odd polynomial. And negative 9, so negative 9 is negative. So we are looking for odd and negative. We come over, and here we find odd and negative. And so those are going to be your answers right there. I can't stress enough that you need to use these helpful notes. And again, you can find them in the October 16th session. All right, the next section asks, find all the zeros algebraically. So what you want to know is, when does this equation x cubed plus 7x squared minus 10x minus 16, when does that equal 0? Now, normally you do synthetic division for this, but if you put this entire equation with equals 0 into your Mathway calculator, it will tell you the 3 answers. And we know it's going to have 3 answers because it's a third degree polynomial. The same goes for the next problem. We want to know, when does x cubed minus x squared plus 35x minus 24, when does that equal 0? All right, we put those in our Mathway calculator, and it will give us 3 answers for that problem. Moving on to the next 2 problems, we are also looking for zeros. And when does f of x equal 0? This graph, this curvy line right here, is f of x. It equals 0 whenever it crosses or touches the x-axis. So when does this graph cross or touch the x-axis? And we can see that it crosses it in those 3 places. So those 3 places are your zeros, your solutions for when f of x equals 0. And so you have 3 answers there, and it's those 3 points, -8, 0, and 4. And the next question is the same. So we can see that in this case, it touches or passes through the x-axis in 2 points. The next 2 questions are about the y coordinate. So if we think about where our y coordinate of a graph is, it's right here. That's the y-intercept for this graph. And it's where x is equal to 0. Right, so here's 1, 2, -1, -2. So we want to know x is equal to 0. All right, so here is our function. So I want to know what is f of 0. Now I could put this function into my Mathway calculator, but it's much simpler to imagine where the 0 would go. Wherever there's an x, we're going to put a 0. Plus 7 times 0, plus 4, plus 9 times 0. Well, what happens to all these zeros? They disappear, and out of that pops out your y coordinate. So you can use that technique for this one and this one. Just put a 0 wherever the x is, and it will tell you what the y-intercept is. The next 2 questions are about intervals of increasing and decreasing. So this asks for where is this function increasing? And so what we're looking for is the interval where it starts and stops increasing. And then we need to describe that in the same way that your graph describes it. All right, so I think we can see that this interval increases from there to there. So this says you name that interval by using the starting point of the interval and the stopping point of the interval, and then you put this in between it. All right? Because this is the way you say between in math. So this graph that I'm pointing at as an example is increasing between -4 and -2. And so that's what I just wrote there. Between -4 and -2, the graph's increasing. All right, so you need to just take whatever the endpoints are of your graph and then put this in the middle. And that works for this problem, and it also works for this problem, but now you have to figure out where does it start decreasing and where does it end decreasing. These next two problems are about positive and negative areas of the graph. And in our positive and negative notes, which you can find in the October 16th session under resources, we see that above the x-axis is positive, below the x-axis is positive. So it's pretty easy to identify where the positive area is. Now all we have to do is name it. And we name it the same way we would when we said increasing and decreasing, is we find the start and the stop point, and then we put less than x, less than in between. All right, because that's how we say between. So in this case, we would say between 3 and 7. So, and this graph is the same, except you have to identify the negative area. Our last two problems are about vocabulary. How do you figure out degree? And the next one is how do you figure out leading coefficient? And in your notes, you have a description of that. And it says that the degree is the highest exponent. In this case, our example, the highest exponent is 5. So that would be a 5th degree polynomial. And the leading coefficient is the coefficient with the highest exponent. So the leading coefficient in this case is going to be 3 because it's with the exponent of 5. And that's all the problems. So good luck on the test, or I hope you did well on the test.